we're here today, folks, to talk about graphing logarithmic functions. I'm honored to have two special guests. We have Zemratrap Sewell and Luhar Karap.
Yeah, I guess.
Yeah. All right. So we're talking about graphing logs, but to do that, we're going to warm up with some evaluating. You guys did pretty good on that worksheet earlier today, so hopefully you'll do well on this. I want to first evaluate log base b of 1. Well, let's see. We said, okay, we're going to set that equal to x, and we're going to read it at an exponential. So b to what power is 1? Well, any base to what power gets you 1? What must that power be? 0. I know that if this argument is a 1, the answer to this log has to be 0. Very useful. I like it when my argument is a 1, because I know the answer to the whole log will always be just 0. All right, take a look at this next example. What if I have log base b of b? Well, in exponential form, this would be b to what power? Is it just plain old b? Well, it's got to be 1, right? So I know this is nice. If I can make my base match my argument, or actually if I can make my argument match my base, I know the answer to this log is always just 1. Take a look at this next one. This is a little bit more challenging. This is b to what power is b to the negative 1 power? Well, that says b to what power is b to the negative 1? Well, obviously it must be negative 1, right? So what this says, now listen to this one. This is important. This says whenever my argument is the reciprocal of my base, I know the answer is negative 1. So I always like for my argument to be the reciprocal of my base because that's an easy log. The answer will just be negative 1. And lastly, take a look at what my argument is now. If I can make this in exponential form, this is b to what power is b squared? Well, it's 2, right? So what this says is if I can make my argument the square of my base, my answer will always just be 2. All right, how is that going to be useful to me for graphing? Because again, we want to be able to graph in the most simple way, all right? Well, I have some steps here that we're going to go through on graphing a log like y equals, actually, I'm missing the letter a log base b of x minus h plus k, all right? The first thing we're going to do is draw a vertical asymptote at x equals h. Let's take a look at why there's a vertical asymptote. Now, we said an asymptote is an imaginary line that the graph should approach. Well, in this case, vertical asymptotes are like an electric fence. They're analogous to an electric fence. Don't ever touch an electric fence or you'll get shocked. On a graph, a vertical asymptote is an electric fence that your graph cannot touch. Why? Because that always represents an undefined amount, right? So let's take a look at this. Suppose that I let x equal to h. Well, that must mean I can plug h in for x. If x equals h, let's replace this x with an h. What's h minus h? 0. Well, that becomes log base b of 0. Would you agree that's undefined? So whatever h is, again, I know there's always going to be a vertical asymptote at x equals h because that gives me undefined. And that, hey, look, it's my daughter with, what kind of donuts? Thai donuts. So you, okay, can we have a sample?
Aren't logarithms fun?
You want one?
I don't know.
I would let you have one, but take the small one.
Luhar.
Can you just skip it?
No, no saving. I'm not dragging this up to the car. It's a perfect number. It's 4.
Really?
Right,
Oh,
right. Sewell,
Seal take
Luhar,
Crap.
donut break.
So good.
What's so good, the log or the donut?
You
Both.
guess.
Avoiding that asymptote.
Put that in there.
They're so
All right, we're back. All right. What we're doing? Oh, we're graphing logs. So we always draw the vertical asymptote first. That's your electric fence. Don't touch it. Now we've got to make an XY table. We want to pick values for x, which make the argument a 1. You want to pick numbers for x that make your argument match your base. You want to make your argument become the reciprocal of the base right here. And you want to pick numbers for your that make your argument your base squared. You plug these numbers in for x and you just solve for y, and those you get your points. After you do that, you connect them with a smooth curve that always approaches your asymptote. Now, in all of these log graphs, your domain will always be from h to infinity, and your range will be from negative infinity to positive infinity. I think that'll be a little bit more clear when we look at the graph. All right, here we go. Let's take a look at an example. All right, to graph this example out, I'm actually going to go split screen so we can see those steps again. All right. All right, here are my steps. Right here. Okay. Let's take a look at how these steps work with this example. I've got log base 2 of x minus 1 plus 2. Well, again, my vertical asymptote should be at x equals h, so x equals 1. And again, if you think about this, just to check, if I plug a 1 in for this x, I would get log base 2 of 1 minus 1, which is log base 2 of 0. And as we said earlier, that's undefined. So I need to draw this vertical line at x equals 1, and I know that I can't touch that. All right, now let's make an xy table. So for my xy table, I think about what I want my argument to be. I want my argument to be the number 1. I want it to match my base. What's my base in this case? I want it to be a 2. I want my argument to be my base squared. Well, 2 squared is 4. And I want my argument to be the reciprocal of my base. So the reciprocal of 2 is a half. That's what I want my argument to be. So what would I have to plug in for x to get that? Well, since my argument in general is x minus 1, if I want a 1 for x, wouldn't I have to plug a 2 in for the x? Now let's do the math. If I plug a 2 in here, 2 minus 1 is 1. Log base 2 of 1 is 0, and 0 plus 2 is 2. Notice that we should hopefully be able to follow what I did in my head. When we graph, we don't have to do a lot of paper, pencil and paper work. We should be able to do this in our head. Now, if I want a 2 for my argument, what would I have to plug in for x?
3.
A 3. Well, that would be log base 2 of 2. What's log base 2 of 2? Log base 2 of 2.
1.
Isn't that 1? Remember, whenever we said this argument, if the argument and the base match, the answer is always just 1. So what's 1 plus 2? 3. So when I plug a 3 in for x, I get a 3 for y. If I want a 4 for x, what would I have to plug in? If I want a 4 for my argument,
5.
what would I have to plug in for x? A 5, right? Let's do the math. What's 5 minus 1?
4.
What's log base 2 of 4?
2.
2, and 2 plus 2?
4.
4. So when x is 5, y is 4. And lastly, the funky one, I need to get a half for my argument. What would I have to plug in for this x here to get a half? Well, what number minus 1 is a half? Isn't it 1 and a half?
Yeah.
So plug a 1 and a half in for x. Now let's do the math. 1 and a half minus 1 is a half. Log base 2 of a half. Wasn't that negative 1?
Yeah.
And that's why I always want my argument to be the reciprocal of my base, because it'll always just be negative 1. What's negative 1 plus 2? 1. So now I'm ready to graph my 5 points. 2 comma 2 is 1 point. 3 comma 3 is another point. 5 comma 4 is another point. And 1 and a half comma 1 is my last point. I graph those out, hugging my asymptote, and that's what my graph looks like. Hey, take a look at this. Would you agree this kind of looks like an exponential turned sideways? Which it should, because remember, they're inverses of each other. So the x's become the y's, and y's become the x's. And that is the graph of a log. Lastly, the domain. Does this graph go to the left forever and to the right forever? No. Doesn't this graph stop at the asymptote? Can it touch the asymptote? No. So exclusive, it starts at 1 and goes to infinity. The range. Does this graph go down forever?
Yes.
Does it go up forever? Yes. Negative infinity, positive infinity is my range, okay? And that's your graph with the domain and range. Thank you, Saul and Luhar.
It's my honor.
It's my honor.
Yeah. It's their honor. Yeah. We'll try to get them more involved next time. See ya.